Okay, guys, can you see my screen?
Yes.
Okay, that's great. So today we will study indexing and slicing. That's a very important topic in any programming language because there is no point in storing data in a data container if we cannot retrieve it or if we cannot access that data back. So it's all about accessing the data. It's all about performing operation on subset of data. So you may come across different scenarios. So, for example, this is a list 9, 50. So 75, 32, 45. So it is possible that you may need to access a single element. You may need to access the element at position. So these are the positions. So 0. So with green, I'm showing the position of the element in the list. So 2, 3, 4. So index is basically the position of the element. So list, you know that each element is separated from the next element by a comma. So this is so we start our indexing with 0, but index itself means the position of the element. So let's suppose that if you want to access this element only, okay. So you can access this element. You want to perform some sort of an operation on this element. You don't need all other elements, so you can access it. So you can we have the means to access it. And there is another scenario. Maybe you need to access the these three elements, which are consecutive elements. So if you want to perform some sort of an operation on these three elements, consecutive elements, so there is a we can do slicing. So slicing helps us to retrieve subsequence of data container. So we can or if you want to access these three elements, or if you want to access maybe uh, these three elements. Okay, so if you want to access a single element, you can do it. If you want to access the elements at consecutive positions, you can also do it. And if you want to access elements with a step size, so let me give you an example. Maybe if I could erase some things here. So this line, this line, this line. Okay, now good. So let's suppose that you want to access the elements at 0th position, second position, uh, position 1. I mean to say, let me. Okay. So you want to access this element, this element, this element. So there is you can also access it because there is a step size. So this we have one element between these two elements. We have one element which we have to jump between these two elements. Okay, so you can also access elements in this way. So if I ask you, what is the way to access all the elements which are completely divisible by 5 in this list, what you will do? This is another scenario. You want to access some element in a list which meets some sort of a Boolean criteria. So how to access elements? So that's a important question. I repeat my question. So how to access elements which are completely divisible by 5? So there is no fixed step size. So 50 and 75 are consecutive, but then we have 32 between them. So obviously we cannot use step size. And you can specify the position of these elements. One way is to specify the position of these elements to access them. I mean, we are going to get, we will do a lot of examples, but here just I want to.
I think we have to make a loop.
Yeah.
First of all, for example, for items in this list, if the Boolean is true, for example, if we divide each item by 5 and the remainder is 0, then we can make a sublist and append the item to the sublist.
Yeah, excellent. So you can loop over each element. You can loop over. Obviously, we have not studied loops yet. We will study it, but we need to know it for indexing and slicing. And usually, indexing and slicing is taught before loops, but obviously, we will also be using loops. So, as your colleague explained it, so there are ways we can loop over each element and check whether an element is completely divisible by 5, then it should be included in the output list. So that's what we will do. So if your list, or another way is to specify the position. So create a list of indices. So what is the index of this 50? It's 1. Okay. Then what's the index of this 75? It's 2. What's the index of 45? 4. Okay, but obviously this is not very convenient. So if your list is very, very large, you are creating the index for all the elements which are completely divisible by 5 by hand. So manually creating it is very, very long, very, very cumbersome. So you will loop over each element. And yeah, so these are the scenarios which you will face. So what type of scenarios you will encounter in? So you may have to access a single element. You may have to access the elements at the consecutive positions. You may have to access an elements with fixed step size, and you may have to access an elements with no fixed size. And we have to be creative how to access an element which have no fixed size, so fixed step size. So yeah, and we will study all these things in detail, and I will summarize it, and you will maybe understand it better what I am trying to explain you now. So okay, now you can. Now let me delete it. Let me delete it. So first thing is indexing. So what is indexing and what is slicing? So first of all, let me define you this indexing and slicing. So this is important. So indexing, basically, if you want to access a single element, so that's single element. Indexing is basically here. If you want to access a single element from any data container, tuple, list, that is indexing. And if you want to access multiple elements simultaneously, that is slicing, or sequence of elements. So slicing. Yeah. And why do you access elements? Obviously, you want to perform some sort of an operations. You don't want to perform operation on all the elements of a list or tuple. You need some elements on which you want to perform some operations. Maybe you want to multiply them. Maybe you want to add something in them. So yeah, so that's why we need indexing and slicing. So let me okay. So here is and always remember that if you are in Python, the counting starts from 0. Actually, like it's the position of the first element is 0, and index is nothing. It's just the position of the elements, and we know list how we classify element in a list or tuple. So in when mean, what do I mean by element? So this is very important. So let's suppose that this is 6, um, 5, so 77, 8, 9, maybe um, so how many elements we have in this list? Anyone?
4.
4. What are they? So this is 6, 5. This is tuple. This is
List.
this is list. So so each element is separated from the next element by a comma. And similarly, this is the definition. This is what I mean by element in a data container. Similarly, you can have a tuples as well, and in which you can store different elements. So that's what the definition of element is. And the position of the first element is 0, second is 1, third is 2, and fourth is 3. So if you are counting, this is the position of the elements if you start from left to right, and if you start from right to left, the position of, you can also specify positions in this way. So this is -1, this list sublist is -1. So next is -2, 5 is -3, 6 is -4. Okay, so this is important. So I mean, you can see indexing in both formats. So from left to right, from right to left. So from if we are indexing from left to right, so the first element to the very left is 0. Okay, questions? Go ahead.
I want to
Question.
find out why are we not starting from -0, but we are starting at -1.
So no, obviously 0 is neither positive, neither negative number. But here it's like we start from -1 when we are doing it from right to left. It's just a choice made by the founders of language. You can think of this. So these are the choices made. Yeah, there is nothing special about them. Yeah. So yeah. Good question. So yeah, okay. So let me now have an example, and when we will see the examples, I mean, we will understand it better. So it's a very important concept. I mean, whether you are learning Python for data science, machine learning, statistics, or even like for some other purpose, very different purpose, you cannot get away with indexing and slicing. The reason is that most of the times you want to perform operations on some selected elements of a data container, and you don't want to perform operations on all the elements of a data container. You want to manipulate some elements of a data container. So that is when you need indexing and slicing. And indexing and slicing obviously in R is also very, very powerful. And maybe you can write more concise code in R, but here it's also very good, excellent. Yeah, so let me erase it so that you don't get confused. Yeah, and don't hesitate to ask questions. I mean, no question is wrong. No question, every question deserves answer. And don't hesitate to ask questions. So otherwise, I mean, if you are not asking question, I mean, uh, there are better videos on YouTube. So the real value of this lecture is to ask question. Maybe your question is the question that is also in the mind of your colleagues, but for some reason they are not asking it. Okay, let me introduce you our list. So this is a list, and this list has 4 elements, and the syntax to get the index, a syntax to get a single element. So you will specify the name of the element, name of the list, name of the data container, square bracket, and the position of the element which you want to access. So what will I get if I run these two lines?
Apple and the cherry.
Apple, you have apple and cherry.
Yeah, apple and cherry. That's great. So the syntax for indexing is a name of the data container, um, and then you give square bracket, and position of a single element which you want to access. This is the position of the element. So position starts with 0, and this will be the position of the element. So that is position of element you want to access. Okay, that is the syntax for indexing. Okay, that's great. Now let me okay. Now we will okay, what is the syntax for slicing? So syntax for slicing is little bit different. So here I have included an example of a string. So strings have character. Okay, strings have character, and it is also an iterable. Remember that string is an iterable, string is immutable. We have not discussed the concept of mutability and immutability. We will discuss it. We are going to have a separate lecture. We will devote a very important lecture tomorrow to discuss mutability and immutability in basic data types and in data containers. And I will also respond to questions which were asked maybe in the first or second lecture regarding the regarding elements of the data container also have reference. That was a question that was asked, and I did not answer it yet, but it's in my mind, and I will answer it tomorrow. Very, very important questions were asked. Yeah. So here we have a string. The name of the string is my string, and variable is nothing but a variable holds a reference to an object at some memory location. So my string is a variable that is holding a reference to this object at some memory location. So here, what we are trying to do, so here, the syntax for slicing. The syntax for slicing is basically you give the name of the name of the data container or name of whatever you want to subset. So this is here the name of this string. Here you can see this is the name of this string. Then a square bracket, and the first number is the start index. It's the start index. The second number after colon is the end index. Okay, this is end index, this is start index. So it will, and start index is inclusive, and end index is not exclusive. So it will give you all the characters from 0 to 5, but 5 is not exclusive. So let me show you. Maybe I should erase it. Okay. I'm talking about this line. Just a second. I'm talking about this. Okay. So what will this give? So capital H is 0, small e is 1, LL is 2, 3, 0 is 4. It will give you hello without comma. Okay, because 5 is, this comma is a separate character, but it is not inclusive. It's exclusive. Okay, so this is what it will give you. So it will give you hello. Yeah, so capital H, small e, double L O. Okay, so that is what it is going to give you. Yeah, and yeah, what I should do, maybe let me let me delete it. Delete all rights here.
Please, I have a question, please.
Go ahead. Sorry, go ahead.
Yeah,
Go
I
ahead.
wish to know if slicing is a synonymous to subsetting, like in R, slicing.
Yeah,
Is this
excellent.
synonymous to subsetting?
Yeah. So both indexing and slicing is are subsetting is a term that we use for both indexing and slicing. So that's what it is in Python. So different programming communities use different uh, lingo, different vocabulary to explain the same concept. And you are right that subsetting. So the slicing and indexing, the combination of slicing and indexing is what we call subsetting in R. Yeah, you're right. Yeah, that's great. That's a great analogy. But obviously, I'm teaching this course only for Python students, and maybe I did not know whether they are interested in R or not. So I did not compare. Yeah. So that's an excellent analogy. Okay. So here, what will this give you? So here, this basically, here this, what about the end index? End index is blank. So what does this mean? In the second line, the end index is blank. So if end index is blank, it means,
To the end of the string.
sorry, say it again.
To the end of the string.
Yeah, excellent. So if the end index is blank, so here we see 7 colon and end index is blank, so it means that go to the end of the string, or go to the end of the
Or-
data
Or a
container.
data container, yeah.
Yeah. So what about if the start index is blank?
Starting from the beginning of the string or from the beginning of the data container.
Yeah, that's great. That's great. Excellent. So that's what it means. So if you see these, have a meaning. So yeah, and this basically you can mix positive and negative index. You cannot mix positive and negative index in R, but you can do it here. So you are. This means so 1, 2, 3, 4, 5, 6, 7. So first will be a character, and it will go to the very end. So this exclamation mark is exclusive because this is -1. So it will go to D. So, okay, it will go to D. So, yeah. So let me run these. Let me run these. So you will see. Yeah, you can see. So here, exclamation mark is excluded. So yeah, this is what you will see. So what do you think? What will I get if I do print my string? What will I get?
You get all the sentence, yellow word, everything.
Hello. Yeah, excellent. So start index is blank, end index is blank. It means start from the beginning of the string and go to the end of the string, or start from the beginning of the container and go to the end of the container, data container. So yeah, that's excellent. So yeah. So here, the general syntax of the slicing is this. Okay, this is the general syntax. So you have a start index, you have an end index, start, and obviously start and end index is separated by a column, and then you have a step index. So if there is no step index specified, it means that it will step by default. Step is 1 by default. So it's 1 by default here. Okay. So yeah, you can even see that. Let me show you. So if I write 1, if I write 1, if I write 1, if I write 1, hopefully you get the same answer, and you get the same answer. So if here I did not specify the step index. So if step index is not specified, it means that it is 1 by default, but you can change the step index if you so like. Okay, so that's important. Now you understand the so, and again, what do we mean by index? Index is nothing but the position of an element in a data container. That's what we meant by index. Yeah, and you can access a single element. You can access multiple elements simultaneously. You can access elements at the consecutive position if you are not, if your step size is 1. But if you want to access elements with a fixed step size, you can also do it. So maybe here, if I increase the step size to 2, you see, so it will, so what does this mean? So this mean basically, I'm here in this line. So it will start from here. Then we have a step size 2. It will 0, 1, 2. So this will be, second L will be here, 0, 1, 2. No, until 5. So 0, 1, 2, 3, 4, 5. Yeah.
It's up to comma.
After comma. Yeah, after comma. So this O will be included. So 0, 1, 2, 3, 4, 5. No. Let me see. Okay. Let me take it to a separate line, and maybe I will able to show you better. So let me create a cell here, or not cell, just copy the code. Okay, let me do this. Okay. See. Okay, so what is this? So what is this? So if I have yeah, HLO, yeah. So okay, so this is what it is. I mean, my eyesight is quite weak. So H L, first L O. So this is what, yeah. So that's why you are getting it. So yeah, so you are using a step size. So you are skipping step size 2 means you are skipping a single element between the 2 consecutive elements. Yeah.
So could you say that it's a kind of a sequencing by 2?
Sorry, say it again, please, loud.
Yeah, I want just to say if it is, we could say sequencing by 2, skipping 2 letters.
Yeah,
Taking
skipping basically we are skipping a single letter. For with step size 2, we are skipping so between we are skipping this E. We are skipping this E. Okay.
Okay, it's understood. Thank you.
E. And we are skipping this L here. So okay, step size of 2 means skipping by a single element. Step size of 3 means skipping 2 elements. And step size 1 means that we are not skipping any element. So yeah, we are yeah. So yeah. So now, okay, that's great. That's great. Okay.
I have question.
Go ahead.
My question is the starting point always the first character. When we use 0:5:2, the starting point.
We can start from any. So here, let me, I can start from this. Okay, let me start from here. 0, 1, 2, 3, 4, 5, 6, 7. I think it is 7, and then go all the way. Okay, so here, so you give start from 7, and you give everything. So you can see that you can extract any you start needs not to be from the first element, or from the very beginning of the string or data container. No, it's not required. You can start from anywhere.
Space value including in this word or character. The space is a count a character name.
Sorry, Again, please.
As for example, HE space LLO. The space is counting the character. Is it here?
Yeah, I mean, you say what's a seven? Seven. I have used seven. Okay, so seven is capital H is 0, small e is 1, L is 2, this is 3, this O is 4, this is comma is 5. Even space will be counted. 6 space is, and if you have two spaces, yeah, so space will be counted. Okay, so capital W is 7. The first element for if you want to start from capital W world, if you want to have a world, yeah, and if you only want, no, if you don't want to have an exclamation mark, you can do something like this. Yeah, this gives you, you don't want to have an exclamation mark. Yeah, so
Or
maybe, yeah, go ahead. Go ahead.
I mean that this point is very essential for data management when we data entry into my Excel data sheet. And there are a lot of space and a lot of characters during my data type and
Yeah.
data entry.
Yeah, so space is counted as a character. So space, I should have mentioned it clearly. The space is a character, and yeah. So let's suppose that if you have string with spaces. So let me give it, okay, string with spaces. 1, 2, 3, 4, 5. Space. So if I want to subset it, okay, if I want to get space from this, okay, so what I will do, Control C, Control V, maybe 0, 1, 2, 3, 4, 3, 3. Let me see. If 3, so we have a space. 4, we have a space.
Yeah.
Yeah, so now it does not have a space. So you are, so first 5, it is skipping first 5 positions because we have a space. So space is a character. Okay, if you have 2 spaces, 2 characters, 3 spaces, 3 characters. Yeah, but obviously, I mean, strings are, I have just included string because maybe I thought that they are easy, but yeah, but obviously we will be working with data containers as well. And our next example is, so if I ask you quickly, how many elements we have here? How many elements we have here? If I use len numbers, what should I get?
It is 10.
10. 10.
Okay, okay, 10. Okay, that's great. So 10 elements. So you can see I'm starting from this 1. Okay, 1, and I'm going 8, but 8 is exclusive. So 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to, yeah, this portion, and then I'm jumping. So
1357.
okay, 135. That's great. That's great. So you got it. So you can get a subsequence with a fixed step size. So yeah, that's great. So again, we can access a single element. We can access a single element from a data container. We can access the elements at the consecutive positions without specifying the step size, or the step size is 1. Or we can access elements which have a fixed step size. So we can subset a sequence, or we can slice a sequence with a fixed step size. So these are the scenarios we can manage now. We have studied the code for it. Okay, that's great.
Imran,
Go ahead.
kindly repeat that again, how you came to the answer.
Okay, so there are basically what I'm trying to explain is we already have studied three scenarios. So scenario one, number one is we can access a single element at any position in a data container. Scenario number one. Scenario number two, we can access maybe let me use the first erase it. Okay, okay, let me erase it. Or should I use this clear order? Okay, first of all, let me show the output. So it is 1357 and explain you how we have come to this answer and also summarize up to now what we have studied. Okay, so this is a list. It has 10 elements. It has 10 elements. So the element, so here, this is the start index. This is the end index and this is the step size. Okay, end index is exclusive. Remember that end index is exclusive. So the position of this element, first 0 is 0. The position of 1 is 1. Yeah. And this position of here, you can, this is position number 8. No, 1, 2, 3, 4, 5, 6, 7. 7, but obviously this is 8. And this is 8. This is 8. But 8 is exclusive. X8 is exclusive. So then you have a step size. So this is the first element that would be included. So the step size is 2. So it means that you have to skip a single one element. So next element is 3. So you have to skip another element. So you have to get 5 and you have to skip another 6 and you have get 7. Obviously 8 is the where you have to end and 8 is exclusive. So you will get 1357. So yeah, and even if you specify, if you increase the step size, if you maybe do it 3, so what do you think what you will get? 147. Okay, so let me maybe I should summarize more than index. I mean more than syntax. I mean it's you need to know what are the scenarios we have covered. Okay, so scenario number one is maybe if this is a list, we can access we can access a single element at any position. So we can access maybe if this element, we can access a single element, any position. We know we do it by indexing. If you want to some subsequence of elements at a consecutive position, let's suppose that you want to access 7, 8, 9, you can do it with specifying step size as 1. Okay, you can do it. If you want to access elements with fixed step size, like you want to skip 1 element or 2 element or 3 elements, that is also possible. So these are the 3 scenarios. We have studied the syntax for these 3 scenarios. Okay, so that's very important. And yeah, okay, let's do a little bit of practice. And okay, so what we will get, maybe I will increase my speed a little bit. So what you will get when you will for these 2 line of codes. So this is a numbers list. This is a numbers list.
3 is 7 and -1 is 9.
Excellent. So you will get, yeah. So you can give an index. So again, so this is, yeah, -1 from left to right. We start counting from -1, -2, 8 is -2, 7 is -3. Okay, so that is, and it is indexing, and you get back a integer. So that's very important. Keep an eye on the type of the data you get back. So that's something very important. Okay, we already have studied. These. If the start index is blank, start from the beginning of the string or beginning of the data container, and -7 specify like, yeah. And if the end index is blank, go to the end of the string or container, whatever it is. And we have studied it. And now, yeah, so you don't need to worry about these. Okay. This is also like not different from what we have studied. So you can maybe practice it at home. So that's not an issue. Okay, 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 okay. Yeah, I mean, yeah, this is not a big deal. Okay, negative step size. So negative step size. So positive step size means you are going from left to right. Positive step size. I'm talking about here we have a negative step size. So it means that you are going from right to left, from right to left. So yeah, so here basically this is a start index. This is a end index and -1. Basically, this will reverse your list. We also have a method to reverse a list, but you can reverse your list in this way as well. Yeah, so step size, you can specify a positive step size, you can specify a negative step size. So here, what this code gives you, this code give you, the two columns give you all the elements in a sequence. And then -1 means I want 5 first, then 4, then 3, then 2, then 1. So -1 is, this is what it meant, what it is meant. Okay, and you can also reverse a string. This is a very convenient way to reverse a string or any data container. Okay, so the another important thing is to keep an eye on what type of object you are getting back. That's a very important question when you are doing indexing and slicing. Very important question. So if you are not paying attention, that will be a big problem. So let's suppose that if you have a list and your list has some nested list, so what you are getting back. Yeah, let me create an example for you that will be that will sensitize you to the importance of because I mean, if you are getting back a list, you cannot perform arithmetic operations on a list. If you're getting back an integer, obviously you can perform arithmetic operations. So it's a very important question. Indexing and slicing, students make a lot of mistakes, and you have to keep an eye on what you are getting back. Maybe let me see. I have an example for. Yeah, here I have an example. That's great. So I'm getting ahead of myself. Okay. Okay, so where is list 1? Where is list 1? Okay, this is a list 1. So it has 1, 2, 3, 4, 5 elements. Okay, and you know that what I will get. So this is indexing. So what do you think? What type of data you will get back? You are getting an integer. So you are getting an integer, and so what type of data you get back depends upon the type of that element as well. So let me create an example here. Maybe that's important. So this is a list 1, 5. This list is ls. The name of this list is ls. It has a tuple 55, 25. Then we have true. So lists are very flexible. You can have elements. You can have each element could be of different data type in a list. So yeah. So if I ls so what will be the return data type if I type this code? What will be returned?
True.
True. So it's a Boolean. It's Boolean. Okay. So if I do instead of 3, if I have 2, what will be returned? What type of data will be returned by this code?
A tuple.
Tuple. Excellent. You are going to have a tuple. So you cannot perform arithmetic operations with tuple. So you need to, you are indexing, and the type of the data that will be returned depends upon the type of the element. So this is, if you're accessing this element, it will be a tuple. If you're accessing this element, it will be a Boolean. It is integer. It is integer. So always keep an eye. Always keep an eye what you are getting back in indexing and slicing. That question is super important. Later on, student makes a lot of mistakes, so that's important. Okay. Um, okay. So obviously, if you are indexing and slicing a string, you will always get back a string. So there is not much difference between indexing and slicing in terms of return data. In terms of return data, but obviously, indexing and slicing yields different results in terms of data for other data containers with nested elements, nested list, or nested tuples. So yeah, I mean, questions are very important. If you have any problem, if you think that, yeah, questions are very important. So here, what will I get? So this is my list 5. So it has like 1, 2, 3, 4, 5, 6, 6 elements. So what do you think? What you will get? What type of data you will get?
An integer.
Yeah, integer. So you will get element 3 as an integer. Okay. So what you will get if you run this code?
I think you will have 2, 3, 4, and 5.
2, 3, 4 as a list. So that's very important. So you are slicing. So you will get back the result as a list. So you will get back elements from 1 to 4, 4 not exclusive, 4 exclusive, but as a list. So slicing will return, if you are slicing on a list, you will get back a list. So that's very important. Okay. And yeah, so I mean, keeping an eye on type is very important. So what type of operations you can perform depends upon the type. So here you can divide an element, but you cannot divide a list because that will give you an error. Yeah, it is giving you an error. Here you were retrieving a sublist. So this list, dividing this list by 10 does not make any sense because you cannot divide a list with with any number, even though all the elements in that list are number. You may need to use for loop, some sort of a for loop. So that's very important, what type of data structure you are getting back. So keep an eye on it. I mean, yeah, that's important. Okay. And this is tuple. I mean, the indexing and slicing work exactly the same way we use it for tuple, but obviously we cannot modify. Okay, go ahead. Question, Moher, go ahead.
Yeah, the previous list that was produced, shouldn't 5 be part of the list?
Okay, let me see. I mean, I did not pay attention to it. Okay, so you are saying that, okay, let me count. So this is 0. This is 0, 1, 2, 3, 4, 5. So 4 is exclusive. So this is exclusive. So you have 1, 2, 3. Yeah, 4 is exclusive. 4 is exclusive. 4, the index 4 is exclusive. So 5 will not be included. So this 1 is inclusive. This 4 is exclusive. So the position of 5 is the element 5 is at position 4, but 4 is exclusive, so that's why it won't be included. Yeah, good question. I mean, it will take maybe a little bit of time, but obviously you guys will it's okay. 0 1 2 3 4. Yeah, so yeah, it will little bit of time maybe. Yeah, but you will ultimately understand that's not an issue. Okay, so tuple and list, as far as accessing an element is concerned, there is no difference. You can access an element or slice an element, a slice sequence of elements from a tuple in the same way as you were doing it in list. So there is no difference. But the main difference is that obviously you can modify elements in a list. So let me give you what you have to do to modify. So let me create a list, a very simple list quickly. So this is a list. 5, 10, 25, 72. So how many elements we have in this list? Quickly.
4.
4. Yeah, LS1. So the name of this list is LS1. So if I want to modify, if I want to replace this 10 with minus 99, I can do that. Okay, I can do that. So what is the syntax for it? What is the syntax for modifying an element? So what you will do, you will write, so first of all, LS1, what is the position of this 10? 0, 1 equals to the element with which you want to modify 10 with. So you want to modify. So this is a general syntax. On the left side of the equals, you access an element. On the right side, you provide the value with which you want to replace the value which you are accessing here. Okay, so this is a general syntax. So if I want to modify this 72 with 50, so what do you think what I need to do? If I want to modify this 72 with 50, what I want to do, what I should do?
LS3 equal 50.
LS1 is the name, LS1 3, you are right. LS1 3 equals to 50. So what's the general syntax? I mean, whether you are replacing an element in any data container. So on the left of the equals to, you have to access an element. So this will access an element. So what will be the result of this element? It will give you basically 72. So this part will give you 72, and you are then on the right of the equals to sign is the value which you want to modify with. So obviously, if it is a tuple, if it was a tuple and all the elements are of immutable type in a tuple, then you cannot replace it. But the situation is quite different if the tuple contains a mutable element like list. But we will study this in detail tomorrow. So you don't need to worry about it. So all you need to know is you can modify using indexing and slicing. Not only you can access element or sequence of elements from list, but you can also modify them. In tuple, all you can do for now, you should think of it. All you can do if your data container is immutable type, you can only access elements. Okay, you cannot modify them in place. Okay, for now, yeah, go ahead.
What if you want to insert between 10 and 25? If you want to insert a number.
Okay, so insert a number between 10 and 25. Okay, so yeah. Okay, I mean, you can use a method, insert method. Do you remember insert method?
Yes, I do.
Yeah. So what you have, okay, this is a good question. So let me, we have a method, insert method. So you can use insert method. So let's use it quickly. I mean, okay, let me, it's an excellent question. Okay, let me raise it 5, 10, 25. I mean, I show you example here quickly, but I think there is a method and we already have this method. Okay. Okay, so let me create a cell here. LS1, 5, 10, 25, 50. So the question is how to insert some element between 10 and 25. That's a question. So how to do it? So LS1 dot insert. So maybe I think the first argument is 0, 1, 2. Let me see, 2 or 3. I am forgetting. So it's maybe I want to add minus 99. So it has lists are mutable. So in place, it would have done it in place. So I should, yeah. So here it has added, so 3 adds an element between 25 and, so I should have done 2. So let me do again. Okay. Yeah, 10 and 25. So this is how you add. So you have a method. You have a method to insert an element between 2 elements. So it's not an issue of indexing and slicing. We already have this this method. So insert is a method that is applied on the object on the object of class list. So yeah, I think we studied it yesterday, and it's good to go through the methods. There are a lot of methods. Actually, I did not cover all of them, and you can study. So yeah, that was a great question. Yeah, thank you for asking this question. Okay, so we have studied this. Okay, let me. Okay, so tuple, I mean, you can access elements from tuple, but you cannot modify them if all the elements of the tuple are of immutable data type. But the story is different if any element of the tuple is mutable, like list, though it's not advisable to have mutable elements in a tuple. But yeah, but we will study it in detail tomorrow. Don't worry about it. So all you need to know for today, that the indexing and slicing works in the same way for tuple as it works for list. That's all you need to know. Okay, now we have indexing and slicing with nested data structure. So if I ask you how many elements we have in this nested list, how many elements, first of all?
3.
3. So that's great. So we have 3 elements, and yeah, and so how to get, so if I want to get maybe yeah, if I want to get only this 5, so how to write so I'm getting a sub element of the second element. So this is my question. So how to get that sub element? Maybe I will run this okay, let me erase it because that is confusing me. Okay, so yeah, here if I create, or first of all, answer me, what will this give you?
4.
So first, so okay, let me explain you. So this will give you the third element, 0, 1, 2. Oh, so it will give you, so you have this list. If you are using this syntax, it will give you this list. And if you want to get back all the elements of this list, then you need to create another a square bracket and start from 0. Okay, so that will give you 7, 8, 9. Okay, so this, what will this give you? Only this. What will this give you?
1, 2, 3.
1, 2, 3 as a list. 1, 2, 3 as a list, and then you want to get 2. I think you will only get 2 here because 0, 1. This one is inclusive. Yeah. Okay. I mean, why I'm asking for the type. Maybe I should have a print statement. Yeah, type is also important, but let me give you the print element to, yeah, print sublist to, yeah, 2, and 2 as a list. 2 as a list. So that's important. So because you are slicing, you will get 2 as a list. Otherwise, if you only want to get 2, 0, 1, so that's what you need to do. Yeah. So whether you are getting back the type of the data you're getting back is super important when you are working with the nested list or nested data structure. So I mean, that's so important, and you should be very clear about it, and you should practice it a lot. So yeah, and maybe if I ask you, keep this in mind, and I want to get 6, this 6. So what should I do? Only this 6. How to access it? 6 as an integer. So first I will like 6 as an integer. So 0, 1. So here I should have 1, and then 0, 1, 2. So here I should have only 2. So this will give you 6. Okay. Yeah, this is important. I mean, practice it, and keep an eye if you are a beginner, whether you are in R, whether you're in Python, whether you are in any programming language, when you are doing indexing and slicing, you should always keep an eye on the return data structure. That's a very important question. That's a very, very important aspect, and student makes a lot of mistakes. Okay. So what will I get if I run this code quickly? Type gives you type, but what will
List.
Yeah, that's great. It will give you a list. And again, what will you get if I run this?
1, 2, 3, 4, 5, 6.
Yeah, or 1, 2, 3, or it will give you 2 only.
It will give 2, yeah. 2.
Yeah, it will give you 2 only as an integer. Because let me show you. This is basically this will give you the whole list. 1, 2, 3. 1, 2, 3. This will give you 1, 2, 2, 3. And then it's just like you are this second square bracket, the index in the second, this will give you 2. Okay, so you will get 2. Yeah, I mean, you guys require, maybe you guys will require a little bit of practice. It's not difficult, but it is important. So indexing and slicing is very, very powerful in Python as well. And you can write very concise code, very readable code. And if you are coming from our background, then indexing and slicing will not be very difficult for you. But obviously, if you are seeing it for the first time, then it may be a little bit of confusing. Again, why do we do indexing and slicing? Because we want to perform operation on some subset of or subsequence of data containers. We store data in data containers, but we don't need all the data in data containers. Maybe we want to perform some operation on some specific data in a data container. So how to access that data? That's a question. And yeah, so what you will get back quickly.
Seven.
No, not only 7, but
7, 8, 9.
7, 8, 9 as a list. So that's important. So that's excellent. And what about this? So this will give you, this part of the code will give you, this part of the code will give you.
Yeah, it will give a 6, 5, 4.
Excellent. 6. Yeah, and this will reverse it. So this will reverse it. So yeah, you can. I mean, yeah. So that's important. So that's important. Okay, 6, 5, 4. That's great. That's great. Okay. Okay. And now, so now we are heading towards another issue that you will face. So you want to access elements which are not in a consecutive positions and which don't follow a fixed step size, which don't follow a fixed step size. So how to access these elements? So let's suppose that I want to access 7. I want to access 9, and I want to access 5. So far, whatever we have studied, we cannot access it with indexing because we are trying to access more than one element, and there is no fixed step size. So I mean, how to access them? We have not studied anything to solve this problem. So you will also face this type of problem. And what you need to do is to use list comprehensions. List comprehensions are very powerful. It is just like a for loop, but obviously it's a little bit tricky if you are a beginner. And obviously I have not covered for loop. We will cover in day after tomorrow. So it's okay if you don't understand it fully, but it is possible to understand it. So what you will do, you will create the elements which you want to access, and elements are not, and this method is very flexible. You can access the elements in consecutive positions. You can access the element which has a fixed step size, and you can access elements which have no fixed step size. Okay, so which have no fixed step size. So previous like what we have studied so far, we cannot solve this problem. We cannot access 7, 9, 5. So what you need to do, you need to create a list, and this list contains the position of the elements. So this 0 is the position of the elements we want to access. This 3 represents the position of 9 that we want to access. This 4 represents the position of 5 that we want to access simultaneously. So you have to create a list of the position of the element. So list of position of the element, and then you need to use list comprehension. So anyone know list comprehension here? Have heard about it? Okay, no problem. So list comprehension is basically a sort of a for loop. Okay, it's a for loop. So what you will do, you will iterate over each element in this indices. So what is this? This portion is like iterate. So I will be 0 in the first iteration. I will be 3 in the second iteration. I will be 4 in the fourth iteration. And here we are just using a normal indexing. And okay, let me again. So list comprehension, first of all, the big picture of list comprehension. So the big picture of list comprehension is here. you have here you are iterating over the sequence. This syntax is for iterating over the sequence, and on the left is what will be returned. So this is a sort of an expression. So this is an expression. You have an expression here, and this should be why it's called a list comprehension, because this is wrapped in a square bracket. So this is wrapped in a square bracket. So you have iteration, for loop to iterate over the sequence, and then you have an expression. So it's okay if you don't understand it yet, because we have not covered for loops yet, and I will cover it in detail. But just to sensitize you that if you want to access,
Can I,
go ahead.
can I
Question?
add something, please?
Yeah, go ahead.
Yeah, is it just like the percentage operator in R? Does it
Yeah,
work like that? Percentage
yeah.
operation.
So membership in is a membership operator, and it's the same as the percentage in percentage. So percentage in percentage is also a membership operator, which checks whether an element on the left is a member of the group on the right. So yeah, so it's a membership operator. So in R we have percentage in percentage. In Python we only have in. So Python, I mean, the code is very readable. If you you can read code as if you are reading a plain English. So I mean, readability of the Python is, I mean, much more than readability of R. R use symbols. Python use keywords like in, not in, is for identity operators, and or is also used in R. But yeah, so yeah, so excellent analogy. So I mean, yeah, it's good if you already know one language, so you can connect it pretty quickly. Okay, oh, this is what it means in another programming language. But obviously, I'm not drawing too many analogies with R, because people who don't want to learn R, they would get irritated pretty quickly. Maybe someday I will offer a course that compare R with Python, and because those who already know R, they will able to learn Python pretty quickly if we draw analogies. Okay, this is what we have. This is the concept in R, and this is what it means in Python. But obviously, Python can do much more than R. And if you are studying NLP, natural language processing, deep learning, R pretty much struggles. NLP, I don't think so. We have good packages in R. I use like Hugging Face, and this is the field where most of the um, development is NLP, deep learning, and R struggles there. But obviously, R has a very powerful visualization capabilities. R has excellent statistical libraries, which Python, I don't think so, can compete. So I mean, both these languages are complementary. Okay, back to list
I'm
comprehension.
sorry, I have a question.
Yeah, go
What
ahead.
is here another list?
Okay,
Is that
that's
an operator or variable? It looks like a variable actually.
yeah. Another
Oh
list
yeah,
is a
okay. I've got it. We just accessed the list, another list. Yeah, okay.
so what will be
It's the name of variable. Yeah.
yeah. So here.
Yeah.
Oh yeah, excellent question. I mean, that's great. So because yeah, here. So
I just missed it. I'm sorry.
no. I mean, that's great. Indices, never hesitate to ask questions. Questions are good. Even I make mistakes. There is a possibility that I make mistake. There's a possibility that maybe there is something else written on the screen and I'm explaining something else. So it's good to make it's good to ask questions, and that's the difference between YouTube video and learning from someone, because you can ask questions. Okay, so list comprehension again. So here, list comprehension has two portions basically. It also have conditional, but here you are iterating over the indices in the list. So what will be the value of I in the first iteration? What do you think? What will be the value of I in the first iteration? So what is the first element in indices?
I think
This is
that
seven.
will be
Zero.
7.
0. Yeah. So yeah, excellent. So yeah. So the I will be 0 in the first iteration. I will be 0 in the first iteration. And what will be I in the second iteration? It will be
This
3. 3.
three.
I will be 4 in the third iteration. So in the first iteration, when I put 0 here, 0 here, so what is the corresponding element which I will index?
7.
7.
7.
For the second iteration, when I is 3, what is the corresponding element which I will
9.
5.
3.
9. 9. 9.
9.
9. 9. Yeah, 9. And the corresponding element for is 5. So yeah. So now if I show you, let me delete it. And let me run the code. So okay, 795. So again, let me summarize you so far. So we know how to access a single element at any position in a data container. We can do it pretty easily through indexing. If we want to access the conjective elements in a data container, we can do so. And we don't need to, we just need to specify step size 1. We can do that. And the third scenario is if we want to access elements and you have to skip a fixed number of elements between those elements, then you can do so with the slicing. All you need to do is to specify a fixed step size. And if fourth scenario is the elements are at different positions which you want to access and there is no fixed step size. What to do then? You need to write a list comprehension. And list comprehension, first you need to do is to create a list of indices, list of the position of the elements which you want to access. And then you will iterate over that list and you will use this type of syntax. So this is expression. Basically, anything that returns a value is an expression. So this will give you. That's a fourth scenario. That's a fourth scenario, and it's the same as the writing a for loop. I mean, for loops are more verbose, so list comprehension is more concise. So people prefer to write list comprehensions. Okay, so yeah, and you can see you can see like this will give you the same result. Yeah,
I have
7,
a
9.
question.
Go ahead.
This means the list comprehension is useful for interval distinct position. But if we consider the continuous position when we use seen that the earliest start in an interval position, but if we use this for I in indices, when I included indices, this is the previous on the list comprehension is working the similar.
Yeah, list
in
comprehension is yeah.
yeah.
So list comprehension is very powerful. You can even use like if I want to access the elements in a sequence, you can use list comprehension. All you need to do is to create the list for the position of those elements. So if I want to do that, if you want to access the elements with a fixed step size, you can use the list comprehension. But if you don't have a fixed step size, then obviously you cannot use previous methods. So list comprehension is powerful, very, very powerful for indexing and
Yes.
slicing. It can replace the previous methods, but I mean there is no point in replacing the slicing, previous slicing. So slicing syntax is more readable, but if there is no fixed step size, then list comprehension. Obviously, you can use list
But when
comprehension.
we use
Go
the
ahead.
sequential interval, then we use earliest. But if we face interval interval position, just then we use comprehension. That's good.
Yeah, when the interval is not fixed, of no fixed step size, so no fixed step size, so interval list comprehensions are powerful. Okay.
Okay.
Yeah, but
Thank you.
obviously, yeah, data container is data containers are very long sometimes, so it is not very convenient to specify the position of the elements. So if this list has 1,000 elements, I mean, and you want to access some
This,
elements which meets some sort of
this,
a Boolean condition. Go
this is
ahead.
very laborious. This is very laborious.
Yeah. So yeah. So if you want to uh, if you want to have a list with like thousand of uh, elements, then obviously specifying the position of all the elements which you want to access is very laborious, as your colleague mentioned. So, but let's suppose that this is a list from which you want to access only even numbers without specifying their position. So still list comprehensions are very powerful. You can do that. You don't need to specify the position of all the even numbers in a data container. So and this is also what you face in R. R also has a very powerful syntax. So yeah, okay, let
In this
me
in
delete
this
it.
case, we use two methods at a time when face these types of situation.
Yeah. So let's suppose that if I ask you, okay, is okay, let me create let me create a, example quickly. So, okay, I think here is no, okay, let me create an example quickly here. So same another list. Just imagine that you only want to access the elements. You only want to access the elements. Only want to access the even numbers. And there is one way is to specify the position of all the even numbers in this list, and that's not very convenient. So how to do that? So maybe you can write even number, some sort of let me see what you have to do. I for I in another list. If I percentage 200, it should give you all the even numbers. Let me see. Yeah. So if, okay, again, so if this is an one way, and if you want to access element which meets some sort of a Boolean condition, uh, then you can access those elements without specifying the position of those elements, without creating a list for the position of those elements. So what I did here, I created a Boolean condition. Okay, so this list comprehension has three parts. Okay, it filters all those elements which don't satisfy this condition. It's a sort of a filter which filters all those elements which don't satisfy this condition. So this checks whether whether the first element is even. If false, okay, no, it will not be outputted. So this is what will be returned. So this I will be returned, and here I'm looping over it. Okay, looping over it. So yeah, obviously I will maybe I think I should stop here, and I should maybe continue this tomorrow. And I also will discuss the mutability. Obviously, I have to like I have to like complete this lecture. Tomorrow. We have a lot of things here, but it's very important for you guys to go through the code. How many of you are? I mean, you are going through the code?